Okay, so next topic is properties of matrix multiplication. First property, matrix multiplication is not commutative in general, na? Okay, it means AB is not equals to BA, obviously. Even sometimes only AB is defined and BA is not defined. Okay, it is also possible, na? So, in a general, matrix multiplication is not commutative. Okay, it means AB is not equals to BA. Remember now? You can't say that AB is equals to BA. Remember. Okay. Now second, if AB is equals to 0, okay, if product of matrix A and B, AB is equals to 0, 0, it means null matrix. Now it doesn't implies that at least one of A or B is 0. Okay, na? If AB is equals to 0, it doesn't implies that at least one of A or B must be 0. Okay. If A into B is equal to 0, it is not necessary that at least one out of A or B is equal to 0 matrix. Okay, na? Actually, example is previously done, but if you want, then see. If you take A as 0, 0, 3, 4 and B as 1, 2, 0, 0. Okay, check for this one. If you multiply AB, what you will get? 0, then 0, then 0, then 0. Okay, in this case, if you find the product matrix AB, you will get 0 matrix. But you can easily see that neither A 0 matrix nor B 0 matrix. Okay, na? So if AB is equals to null matrix, it is not necessary that at least one is 0. Okay, if both are non-zero, then also the product may be null matrix. Okay, third one. If B is equals to C, then obviously AB is equals to AC. Okay, but if B is equals to C, then AB is obviously equals to AC. But if AB is equals to AC, it doesn't implies that B is equals to C. Okay. If B is equals to C, then AB is obviously equals to AC. But if AB equals to AC, then you can't say that B is equals to C. Why we can't say? Actually, na, simply C. If you write this one at this side, then what we are getting? A common, then B minus C. Okay, equals to 0. Now product matrix is 0 matrix. Now it is not necessary. Actually, when you will get B equals to C, you will get B equals to C if you are getting B minus C equals to null matrix. Now it is not necessary that this one is null matrix. Okay, now so you can't say that B equals to C. If this one is null matrix, then we can say that B minus C equals to null matrix, then B equals to C. Okay, otherwise we can't say, na. And we know that if A into B, product of two matrices is equals to null matrix, now it is not necessary that at least one out of these two is 0. Okay, so you can't say that B equals to C from AB equals to AC. Fourth one, A into B plus C is equals to AB plus AC. Okay, this one into this one plus this one into this one. Okay, remember that in matrix multiplication order matter. Okay, na? You can't write A after B. Okay, na? So A is this one, na? So A into B, it means AB, then A into C, it means AC. Okay, not CA. Fifth one, A square. A square, it means A into A. A cube. A cube, it means A square into A. Again A into A 3 times. Okay. Similarly, A power n. A power n, it means A into A n times. Okay. Eighth, if you multiply any matrix with identity matrix, it means multiply A into I or I into A. In both case you will get A. Okay, A into I, if you multiply any matrix with identity matrix, then you will get again same that matrix. Okay na? So A into I into A is equals to A. Okay, and ninth one, if AB is equals to BA, then A and B is said to be commute each other. Okay, if AB is equals to BA, then A and B, they are not equal in general, but if they are equal, then A and B is said to be commute of each other. Okay, and similarly, if AB is not equals to minus of BA, then A and B said to be anti-commute of each other. Okay, so if AB equals to BA, then A and B are said to be commute each other, and AB equals to minus BA, then they are anti-commute each other. Okay, and last final 11th, A plus B whole square, A plus B whole square, it is not equals to A square plus 2AB plus B square. Remember, in matrix multiplication, A plus B whole square is not equals to this one. Actually, A plus B whole square, it means A square is A into A. So A plus B whole square is A plus B into A plus B. And if you multiply this one, then what we are getting? A into A square. Okay, then AB, after that BA, and after that B into B square. Okay, this is the value. A square plus AB plus BA plus A square plus B square. Okay na? So this is not equals to this one. This is not equals to this one. This is equals to this one. A square plus AB plus BA plus B square. Okay, any problem? So these are clear na? Write down. And this is for any square matrix, obviously na, because if A is not a square matrix, then how can you multiply A into A? Suppose order of A is 2 by 3. If order of A is 2 by 3, then A into A, this is also 2 by 3. Now these two are not same, so product is not possible. So A square, A cube, these are for square matrix. Okay, thank you. Write down. Can I have? Okay. So remember, if AB equals to null matrix, now it is not necessary that at least A or B null matrix. Okay na? It is not necessary. Okay, after this one, next what we have? Okay, see. Write equation. Find matrix X and Y such that two x minus y is equals to 6 minus 6 0 minus 4 2 and 1, and x plus 2y is equals to 3 minus 2 2 1 5 minus 7. Okay, you want matrix X and Y so that this one is equals to this one and this one is equals to, it will solve the matrix equation. Okay, now easily, actually this is matrix now, capital X and capital Y. Now how to get X and Y? Simple, solve as equation. solve as equation. Okay na, algebraic equation same. Now we want value of x and y. So to solve these, at least one must be cancelled out now. Here we have 2y, here we have only y. So multiply first this one with 2. If you multiply this equation with 2, then this will be 4x minus 2y. Okay, y is capital na. Okay, so 4x minus 2y. Now multiply 2 with this one also na. I am multiplying with 2. So this complete equation. Okay, so 4x minus 2y. Now 2 into this one is every element is multiplied by 2. Okay, 12 minus 12, 0 minus 8, 4, 2. Now coefficient is same. Now I can add na to cancel out y. And next one is x plus 2y equals to 3, 2, 5, minus 2, 1 and minus 7. Now add to get value of x. If you add minus 2y plus 2y cancel out, what we are getting? 5x. Now how to add the matrices? Simple, add corresponding elements. Okay, so this one plus this one 15, this one plus this one minus 10, this one plus this one 5, minus 8 minus 2 minus 10, 4 and 1 5, and 2 and minus 7 minus 5. Okay, okay, now what do you want value of x? So divide with 5. If you divide with 5, here we are getting 1 by 5. 1 by 5 inside, then multiply with every element. It must divide with 5 to every element. So x is equal to, if you divide with 5, then every element. If you are dividing any matrix with a constant, with a constant, then we have to divide the whole element by that constant. Okay na? So 15 by 5, 3, minus 2. We are dividing with 5 na? Okay, and 1. Minus 2, 1 and minus 1. Okay, so this is the matrix X. Now what do you want? Y. Put in any equation to get y. Okay, if you will put x in this one, and this is the equation number 1. Okay, then 2y is equals to 3, 2, 5, minus 2, 1 minus 7 minus x. 2y equals to this one minus x na. Value of x is 3 minus 2, 1 minus 2, 1 minus 1. Okay, subtract. How to subtract? Subtract corresponding element. Okay, so what we are getting? 3 minus 3, 0. Very good. 2 minus minus. Now this minus minus become plus now. So 4. Okay, 5 minus 1, 4. Thank you. And minus 2 cancel out, 0. 1 1 cancel out, 0. Okay, and minus 7 and plus 1. This becomes, so minus 6. Now divide with 2. This is the value of 2y na. Then y is equal to, if you divide all element with 2, then 0, 2, 2, 0, 0, minus 3. Okay, done. So this is x and this is y. No problem. Okay, write down. Okay, can I rough? मैं कर देता. Now next, a matrix has 12 element. Find number of possible order it can. Okay, so what do you want? Number of possible order. So first, all possible order. We have total element. So I can make a matrix of the order 1 is to 12. 1 row, 12 column. Okay na? Total element is 12 na. So 1 is to 12. Can I take 2 row? If you are taking 2 row, then you will get 6 column, because m into n is the number of element. Okay, 3 into 4, 3 row, 4 column, then also you will get 12 element. Then can I take 4? Yeah, 4 by 3. Now I can take 5 by something now, because 12 is not divisible by 5. Then 6 by 2, and then after at the end 12 by 1. So how many possible order we have? We have 6. Number of order. Okay, that write down. Now next thing, matrix polynomial. Okay, this is now 1 minute. Yeah, matrix polynomial. So next is matrix polynomial. Now what is the matrix polynomial? Simple. Polynomial in terms of matrix known as matrix polynomial. Okay, actually polynomial in X is, if you are writing any polynomial function in X, polynomial in X, okay, then polynomial is a n x power n, a n minus 1 x power n minus 1, a n minus 2 x power n minus 2. Okay, a1x a0. This is the general polynomial in X. Okay, now a0 plus a1x plus a2x square at the end a n x power n. Okay, in polynomial power of x must be non-negative integer. Okay, you can't take power of x as 2 by 3, 5 by 7, 1 by 2. Okay, no. So this is the general polynomial in X. Polynomial in X. Okay, this is the polynomial in X. But what do we want? We want matrix polynomial. So replace X with a matrix. Then you will get matrix polynomial. Okay, see. F A. Suppose A is any matrix and square matrix. Okay. Why only square matrix? Because if A is not a square matrix, then how can you find value? How can you find matrix a power n minus 1? Simple thing now. Okay, if A is not a square matrix, then A into A is not possible now then. Okay, so replace X with A, then what we are getting? A n a power n. Now here A is a square matrix. Okay, a n minus 1 a power n minus 1, a n minus 2 a power n minus 2. Okay, at the end a1 a. Now plus a0. Now 1 minute. Actually this is the matrix polynomial. So all terms, this one is matrix, matrix. These all terms are matrices. Okay, here an is constant, but if you multiply any matrix with constant, then you will get again matrix. So every term represent a matrix. Okay, but see a0 is only constant. Now it is not possible now. Okay, this must be a matrix term. Okay, every term must be a matrix now, then you will get matrix polynomial. Okay, so for in polynomial, if you have any only constant term, then write this one as a0 into I. Okay, here we didn't have any x now. Suppose I can say that this one as, then write this one, sorry, write this one as a0 into I for constant term. Now this is also matrix. Okay, so this is the matrix polynomial. Matrix polynomial. Here A is square matrix. Okay, and if FA equals to 0, okay, in any polynomial, if we are replacing x with A, then you will get a matrix polynomial. If value of this matrix polynomial is equals to 0, then A is said to be root of matrix polynomial. Okay, so then A is the root of matrix polynomial. Okay, then A is the root of matrix polynomial. Simple thing na. So any polynomial, if you want matrix polynomial, replace x with the matrix A, okay, and replace constant with a0 into I, because every term represent a matrix now, so this should be matrix, okay. And if fa equals to 0, it means value of this one equals to 0, then a is said to be root of this matrix polynomial, okay. I am taking one question based on this one. See, write a question. Let a is equals to 2, 3, minus 1 and 2, okay, and fx is equals to x square minus 4x plus 7. Show that fa is equal to 0, okay, and use this result to find a power 5, okay. Now see, a is given, fx any polynomial, so that fa equals to 0, it means a is the root of this polynomial. But first, how to find fa, okay. Actually fa is replace x with a matrix, okay, then you will get a square minus 4a plus 7. Now we can't write 7 now because every term must represent a matrix, so 7i, because there is no x, so we can't put a now, okay. So this is the fa. Now I want this one, so to get this one, what do you want? We want a square, okay. Then first find a square. A square is a into a is 2, 3, minus 1 and 2, a into a 2, 3, minus 1, 2, okay. Now just multiply. One thing is clear, if you multiply this matrix, then you will get a 2 by 2 matrix, obviously. Then a11 is first row first column, okay. Now first row first column, then 4 minus 3, what we are getting? 1. Now P12 product matrix, P12, it means first row second column, okay now. So see, first row and second column, 6 and 6, 12, okay. Now P21 second row first column, minus 2, minus 2, minus 4, okay. Now P22 second row second column, minus 3 and plus 4, then again 1. This is the value of a square. Now easily we have 4a and 7i, so just put the value. Now again fa, a square is a square, this one 1, 12, minus 4 and 1, okay, minus 4a, it was multiply a with 4, then what you will get? 8, 12, minus 4 and 8, okay, and plus 7i. Actually I is identity matrix of order 2 by 2, because order of a is 2 by 2 na, okay. So 2 by 2 identity matrix is 1 0 0 1, but we have 7i, okay. Then multiply with 7, what you will get? You will get 7 0 0 7, okay. Now add these, what we are getting? 1 minus 8 and plus 7, 0, okay na. Add or subtract corresponding element na. 12 minus 12 plus 0, again 0, minus 4 plus 4 plus 0, again 0, plus 1 minus 8 and plus 7, plus 8 and minus 8, again 0, okay. So we are getting that fa is equals to 0. It was null matrix, okay. So first part is done. That is the first part. Now use this result to find a power 5, okay. How to use? Can I rub this one? Write down first, okay. Can I rub up to this one? Now what do we want to use this result to find a power 5. Okay, now result is fa equals to 0. It means we are getting that a square minus 4a plus 7i, this is the fa na, equals to 0. From this one what we are getting? From this one we are getting that a square equals to 4a minus 7i. These matrices at this side. Okay, now we want to use this result to get a power 5. Okay, then multiply this one with a, then you will get a power cube, then again multiply with a, then you will get a power 4, then again with a, then a power 5. So if you multiply with a, then a, okay, I am at the side, a into a square is a cube. Then here you are multiplying with a, then a into 4a, 4 is constant, so outside, so a into a square, a into 7i, 7 constant outside, a into I is a. Okay, but we want value of this one. Now again you can put value of a square. Okay na? So see, 4, value of a square is 4a minus 7i, and this is minus 7a. Okay, now you will get value of a cube. A cube is 16a, 16a minus 7a, 9a, and minus 28i. Okay, this is the value of a cube. Now again multiply with a, then you will get a power 4. Okay na? So a power 4, multiplying with the a into a cube, a power 4. Again here also we are multiplying with a, then what you will get? 9a square minus 28a into I, then this become a. Now again put value of a square, 9 into a square value is 4a minus 7i. Okay, now if you solve this one, 36a minus 28a, so what we are getting? 8a, and 9 into 7 is 63, 63i. Okay, this is the value of a power 4. Then again multiply with a power 5. A into a power 4 is a power 5. If you multiply this one with a, then 8a square minus 63, a into I, that become a. Okay na? Product of any matrix with identity matrix is always equals to that matrix na. Okay, now again put value of a square. A square is 4a minus 7i. Okay, and minus 63a. Now if you solve this one, then you will get 32a minus 63a, minus 31a, and minus 56i. Okay, now just put the value of a and I, you will get the answer. Okay na? Minus 31, a is 2, 3, minus 1 and 2, minus 56, okay, and I is 1001. Okay, now just add, you will get the answer. I can't add or subtract now. No, okay, I am doing minus 31 into 2, minus 62, minus 62 and minus 56. Oh, so minus 118. Okay na? Kana? Okay. Minus 93 minus 0, minus 93, plus 31, 0, so 31, minus 62 and minus 56, again minus 118. Okay, so this is the a power 5. Okay, can I rough? Done now? Okay, write down. Pause and write down.